This is problem 10. We've got a deposit of 100 made at time equals 0, a deposit of x made at time equals 3. We're going to accumulate with this force of interest, and the interest earned between time 3 and time 6 is the same as the deposit that was made at time 3, and we want to know the value of that deposit or that interest earned. So I've got the timeline written out here. Year 0, deposit 100, time 3, deposit x. Done accumulating at time 6, and between the interest earned between time 3 and time 6 is also x. So if we didn't have this deposit right here, this would be a very simple problem. We would take the accumulated value at time 6 and subtract off the accumulated value at time 3, and that would give us the interest earned right here. But let's have a close look at this, right? If we have the accumulated value at time 6, that's going to be this 100 accumulating for 6 years, plus this deposit of x accumulating for the last 3 years, and then our accumulated value a of 3 would just be this 100 accumulating for the first 3 years. So we've got to account for the fact that we made an additional deposit while we were accumulating in order to get to the interest earned. So I'll come back to that in just a minute. Let's go ahead and get values for a of 6. That is $100 or 100 whatevers, accumulating at a force of interest from 0 to 6, plus x dollars, accumulating at a force of interest from 3 to 6. I'm going to assume that you can resolve this integral yourself. If you can't, while there is minimal calculus on exam FM, this sort of basic power rule stuff is something you got to know. So we end up with e to the 0.72 plus x times e to the 0.63. So there's our accumulated value at time 6, and our accumulated value at time 3 is a little bit simpler. It's just this 100 times the force of interest for the first 3 years, which resolves quite nicely to 100 times e to the 0.09. So now let's go back to the original equation we wrote and put it all together. We have the accumulated value at 6 minus the accumulated value at time 3 and then minus the deposit that was made at time 3 will equal the interest that was earned between time 3 and time 6, which is the same as the deposit. So you can see here why we need to take x off. If that wasn't immediately obvious, being honest, it wasn't obvious to me on my first attack of the problem. I had to come back and think it through more closely because I missed that subtraction of x, but it really makes a lot of sense, right? If we only want the interest, then that means we have to subtract out the principal of both the initial deposit of 100, which we have done, that's baked in, but also the deposit that happens at year 3. Without subtracting this x, then we never account for the fact that we only want the interest earned on payment x and not the total amount earned. So with that in mind, from here on it is just algebra, and like I've said in previous videos, really this is the hard part. It is writing the correct equation first, but if you write the correct equation, then once you get to the end or the 2/3 of the way through, it really is it really is just algebra. So let's collect our constants here, and the calculator would be really helpful. We get about 96.03. Let's collect the x terms here. So this is just e to the 0.63 minus 1. We have that many x's, which is 0.8776x equals x. Collect our unknowns on the same side of the equation with subtraction. 96.03 is equal 0.1224x. And finally, division gets us to our final value of 784.6, which would round up to 785. So the final answer here is E. And it bears repeating one more time. For just about every question on Exam FM, half the battle is setting up the correct equation. And if you write out a nice timeline and think through each piece, writing that initial equation is less difficult. And then once you've got the correct equation, you're just doing algebra or maybe some pretty simple calculus.